Hey guys, so today we will take the question on arrays. Find the maximum absolute difference. So it's maximum absolute difference. So we are given an array. So we have to find any two indexes I and j where I is not equal to j, for which the given function has the maximum value. So the function is f of I and j is difference between their value. So modular difference between their values, that is area of I minus area of j plus the modular difference between their indexes, that is I minus j. So let's see an example. For example, we are given an array 1, 3 and minus 1. So what all combinations are possible? 1 and 3, 3 and minus 1, 1 and minus 1. So what is the difference of the values between 1 and 3? That is 2. And what is the difference between their indexes? That is 1. So we get the answer as 3. For 3 and minus 1, what is the difference between their values? That is 4. And what is the difference between their indexes? That is 1. So the answer becomes 5. And for 1 and minus 1, the difference between the values is 2, and the difference between their indexes is also 2, so the answer becomes 4. So the maximum of all these three is 5, so our the final answer should be 5. Okay. So we saw how we can solve it using brute force. We just need to iterate this array and traverse or iterate all the possible combinations of I and j, and then just try to calculate the function value and keep track of the maximum value. So that will be solved in order of n square complexity. Let's try to see how we can solve this in order of n. So for that, first of all, let's see how we can expand this function. So case 1, array of I will call it as a of I is greater than a of j, or sorry, it's less than a of j, and I is also less than j. So in this case, how will this function expand? So answer will become array of j minus array of I plus j minus I, which can be written as array of j minus, sorry, it's plus j minus array of I plus I. Now let's see the case 2. So the case 2 is array of I is greater than array of j, but I is less than j. So for this, how will the function expand? Array of I minus array of j plus j minus I. We can write it as array of I minus array of j minus j, right? Now let's see the case 3. Here array of I is less than array of j and I is greater than j. Here our solution will be array of j minus array of I plus I minus j, which we can write as array of j minus j minus array of I minus I. And this brings us to our final case 4, where array of I is less than, array of I is greater than array of j and I is greater than j. Here our solution will be array of I minus array of j plus I minus j, which can be written as array of I plus I minus array of j plus j. So now we have expanded our function. Let us see what all 4 values we have. So if you consider these 2 values, these are exactly the same, just the position of j and I are switched. So this is one case. And the other one is these are also just the position of j and I are switched. So in total, we have only 2 possibilities, which is array of I plus I minus array of j plus j. This is our first. The second is array of I minus I minus array of j minus j. I hope from this point onwards it's quite evident to see what is going to be the solution. So now we have established that the answer could be either of two values, whichever is the maximum. So let's see what is the first value. First value is a of I, which is the element itself, plus its index. This is the first term, minus the second term. Second term also happens to be the same, array of j plus the index. So it's as good as if we can somehow find for each and every index of the array the value of the element plus its index, then it's just a matter of finding the absolute maximum and difference between the maximum value for that term and the minimum value of that term. So if I have an array 1, 3 and minus 1, what is going to be the value of element plus the index? So I will write index here 0, 1, 2. So what is this? Let me call this as sum array. So the value of at 0 index, the value becomes the element plus the index, that is 1, 4, 1, right? So now for each and every element, for each and every index, we know what is the value of the element plus the index. Finding the absolute difference between the max and minimum term for this array is also possible in just one traversal. So we traverse this array, keep track of the minimum and keep track of the maximum. So that is quite easy. So we don't even need two traversals, we can do it in one single traversal as well. So as we can see, the difference between these will be 3. 4 minus 1, that is 3. So maximum value is 4, minimum value is 1, so the difference becomes 4 minus 1, that is 3. Similarly, let's calculate the second term. Second term is a of I minus a of j minus j. So I'll write this as difference. So 1 minus 0 is 1, 3 minus 1 is 2, and minus 1 minus 2 is minus 3. So what is the minimum value here or the maximum value here? That is 2, and the minimum value here is minus 3. And what is the difference between them? That is 5. So we got our two possible solutions, one is 3, one is 5, and the maximum of these two is our answer, that is 5. So this is how we solve this problem. See you next time.